So in this video, we're going to graph a linear function that's written in standard form, and we're going to do it by finding the intercepts of that function when the intercepts have non-integer values. So here I have a linear equation or linear function in standard form. It's in the form ax plus by equals c. And so if I'm looking at pi times y plus the square root of 5 x equal to 11, what I see is that the b is actually equal to pi because b is the coefficient on the y term. I see that a is the coefficient on the x term, so a has to be the square root of 5, and c is equal to 11. So I have real number coefficients. They just don't happen to be nice integer values, and that's okay. The concept is the same as it's always been. We know that if we have an x-intercept, then we know that even if we don't know the x-coordinate, we know that the y-coordinate has to be 0, and we know if we have a y-intercept on the y-axis, we know that the x-coordinate has to be 0, even if we don't know what the y-coordinate is. So to locate the intercepts, we do exactly the same thing that we've been doing. We say, hey, to find the y-intercept, just take and let x be 0 and figure out what the y value is that goes with it. So I take my equation pi times y plus the square root of 5 times x, but I replace the x with 0, and I solve for y. So 0 times root 5 is just going to be 0, so I'm going to get pi times y equals 1, and I'm going to get y equals 1 over pi. So my y-coordinate when x is 0, y is equal to 1 over pi. There's my y-intercept. And to find the x-intercept, we play the similar game. We just come in and replace the y-coordinate now with 0. So we go pi times 0 plus the square root of 5 times x equals 11. Pi times 0 is 0. 0 plus root 5x is just root 5x, and that's going to equal 11, and then divide both sides by the square root of 5, which is the coefficient on the x term or the x variable. So we get 11 divided by the square root of 5. So the ordered pair we get is when I input 11 over the square root of 5, the output is going to be y equal to 0. So there is my x-intercept, and here is my y-intercept, and now I can go ahead and graph those. So I'm going to set up my axes. And this is the y-axis, and this is the x-axis. I have arrows on all of my number lines. I step over here and I say, what is this? Well, pi is about 3. So this is the ordered pair 0, 1/3. So on the y-intercept, we probably wouldn't be going up very high because the y-coordinate's only about 1/3. And down here, when I look at this, I can get an idea for what this is too. This is 11 divided by the square root of 5. But if the square root of 4 is 2, if the square root of 4 equals 2, then the square root of 5 has to be pretty close to that, right? And what's the next perfect square up? Square root of 9 would be the next perfect square up, and the square root of 9 is 3. So the square root of 5 has to be between the square root of 4 and the square root of 9, but it has to be closer to the square root of 4 than it is to the square root of 9, because 5 is closer to 4 than 5 is to 9. So it's going to be a number that's a little bit bigger than 2. And so what we're doing is dividing a number a little bit bigger than 2 into 11. So to estimate this, just mentally, I would go 11 divided by 2 is what? About 5.5? Yeah. Okay, so I need to be on the x-axis, I need to be over about 5.5 units and only up 1/3 of a unit on the y-axis. So to get a rough picture of this, I don't need to get this perfect. To just get a rough picture of what's going on, I'd swing through and make sure I intersect the y-axis pretty low and try to draw the x-axis intercept out a bit further. So that wasn't my best attempt. angle my body and try to get this. So I've got to have a shallow angle. The key is I need my angle to be really shallow, so we can intersect the x-axis way out here. And again, the idea is we're not going to get these. We're not going to get this perfect. You're just trying to get a picture that roughly tells the reader what's going on. There, that's good enough. We can have a different scale on the y-axis than the x-axis. The idea that the line is shallow because it doesn't go up high and it has to hit much wider, this picture captures that. So then you just label your intercepts. This is the intercept right here. Input 0, output 1 over pi. And here this intercept is input 11 over the square root of 5. I'd like my square root of 5 to show up better. Input 11 over the square root of 5, and the output is 0. And it says find the domain and range, but we already know that if it's not a horizontal line, we already know by previous work that we've done that the domain is going to be x going from negative infinity to infinity, and the range is going to be the outputs or the y values also going from negative infinity to infinity. And this is the hallmark of a linear function if it is not horizontal.